Hi everyone, a very good morning. Today's topic is conductor. Way people looks at it, in a very complex way, like where to put the charge, where to take the charge from, how to distribute the charge. Think these the kinds of things keeps the people in a lot of trouble. But we are going to make it very simple today, very simple. We will study from the basics and we will go up to the very high level, up to J advanced level. Like gradually we will go and keep it in mind. Physics is nothing like you have to study from the top level only. First, understand the basics, understand the concept, and then you can just apply it at the most, at the most top level. So we are going to start from the very scratch. And first of all, let us know what is conductor. Okay. So there are three kinds of body in this aspect. First is your conductor. Second one is your insulator. And third one is your semiconductor. Okay. Now let us understand what exactly all three leads to. First one is conductor. Conductor simply means infinite free electrons. Very basic definition. We won't go into complexity. Very basic definition. Infinite free electrons. Insulator. No free electron. And third one is semiconductor. So it is a kind of different. It is a kind of mixture of conductor and insulator. It behaves in different manner at different temperature. Like if you look at the semiconductor at 0 Kelvin, it behaves like an insulator. And if you raise the temperature, high temperature, then it behaves like a conductor, more or like a conductor. So it has some different kind of nature, like in solar panel or other things. We will semiconductor. We won't be going into this. There is a separate chapter on this semiconductor topic. We also going on this insulator part as of now. What we are going to discuss is conductor. So first thing is infinite free electrons. It simply means, let us say, if you have infinite money, a huge amount of money. Okay, and I'll go and ask, like you are the owner of 10 billions of rupees. Like you have a house, you have a villa, and the whole 100,000 and lakhs rupees of notes are like the villa is full of the notes. Okay, so a child goes and take a note, right? Let's take a 10 rupees note. So there is 10 billion, 100 billion, 1000 billion. Will the owner of 1000 billion rupees will ask you, hey boy, you can't pick up this 10 rupees note? Will you tell him, no, you won't? 10 rupees, man. 10 rupees is nothing in front of this 1000 billion rupees. So you just pick it up and okay, you will go. Then next some another guy will come. So whoever comes, a blow of air. Let us suppose air is blowing at very high speed and this villa is like the windows are open and notes are filled, something like this. So the air will blow the house and so many notes from the house will blow, get out of the window and this is the notes like air, Gandhiji in the notes. And all the notes are in the house, air comes and air blows and few notes, 10 rupees notes, 100 rupees notes, 1000 rupees notes will get out of the house. So this is the situation of conductor, free electrons. There is no one to attract these electrons. Whoever goes, okay, give me some electrons, take it, finish. This is something like that situation. Free, everything is free. But assume a situation where you have just 100 rupees. You have just 100 rupees. And someone comes and asks you, please give me 50 rupees. Will you give? No, you can't. Because you have only 100 rupees. Or if you have 10 rupees and someone comes and asks, please give me 10 rupees, you can't. Does any boy come daily and take that 10 rupees that easily? He cannot. This is the situation. So that is that 10 rupees situation. If you have just 10 rupees or 100 rupees, that is the situation of insulator. And if you have infinite free electrons, infinite amount of money, even if anyone takes that money, 10 rupees or 100 rupees or 1000 rupees, you don't even care about it. So that is the case with the conductor. And this is a very basic thing. And if we can understand this part, we can understand any part of the conductor. Okay, so this was just an example for explanation. So if there is a conductor, like there is a body, a conducting body, so it has electrons, infinite number of electrons everywhere, like electrons, and these electrons are known as free electrons or conduction electrons. Free electrons or conduction electrons. Why conduction electrons? That I am going to explain. First of all, frankly speaking, normally all the metals are conductors and non-metals are non-conductors. Why? That I'll explain. I'll take you for 1 minute of yours and I'll explain it by chemistry, using chemistry. So first of all, get metal. Just take an example of a metal like aluminium. Okay. Now let us consider aluminium. It has 3 electrons in its outer orbit. So anyone goes, okay, give me just 3 electrons. Cl goes and asks, okay, give me 1 electron. 3 Cl atoms ask, and all of the 3 chlorine atoms takes it 1 electron, and the compound form is AlCl3. So all the 3 electrons are taken by Cl, and aluminium get plus 3 charge. Why? Because it has so many free electrons in the outer orbit. While Cl, it will never give you electron. Because this is kind of insulator. It will keep its electrons with you. There is no free electron. So that is why normally metals which have free electrons and non-metals which have no free electrons. And why these free electrons are known as conduction electrons? Because when we apply a potential difference between 2 points of a conductor, there is a current. And the current is carried by those free electrons. The current is conducted by those free electrons, and that is why those are known as conduction electrons. Now we will go more deeper. So this is the very basic: free electrons, conduction electrons. It is responsible for conductivity of a metal. More free electrons, more conductivity. Loosely bound. Also you can say loosely bound. Now, like, there is no guardian for this kid. If a kid who has no parents, who does not live with parents, that is loosely bound. Anybody will come and say, hey, do this, hey, do that, and he'll do that. But if a child is with parents, he won't do anything. So this is loosely bound electrons. Okay. So this is a very basic property and a very basic definition of conductors. They consist a lot of infinite, but just skip it, just insert your mind that the conductor has infinite number of free electrons. Whenever needed, this will go here and there. Infinite number of free electrons. And based on this assumption, based on this hypothesis, we will derive and we are going to do everything. Okay, so first of all, let us take a conducting body. Any irregular shaped body. Okay, any irregular shaped body. What will happen here? And let us keep this body in an existing electrical field. I am showing this as the direction of electric field. This is the existing electric field in that space, whose value is given by E, magnitude E vector. Okay, so this is the conductor. Now, this is the conductor whole filled with conductor. Now what will happen, as we already discussed, this has infinite number of free electrons. What will happen with this conductor? Conductor, it is electron here, everywhere. Okay. So we know if a charge is placed in an electric field, if there is a charge Q and that is placed in an electric field E, so there is a force on this charge, and which is equal to force equal to Q into E. Similarly, electrons are there. So electrons are nothing but charge which are charge of minus E. So if there is an electron kept in an electric field, the charge on the electron is minus Q, minus E. E is the charge Q into E. Minus sign indicates that the force on electron will be opposite to that of electric field, which means if electric field is existing in this direction, the force of the electron will be E in this direction, right? So that means on this electron, each and every electron there is a force whose magnitude is E in small e into capital E, because electric field in this case is uniform. So let us say here the electric force is E into E, E into E, E into E, E into E. There are infinite, I am just showing few like 5 to 6, but there are infinite such kind of electrons. What will happen? All these electrons will feel a force in negative x direction. And we discussed free electrons. What does free word mean? Free means they are loosely bound. They are loosely bound. That means they can move anywhere with a very small amount of force. You can take them anywhere. So that means these are free. Nobody is there to control them, and these electrons will start moving in negative x direction. Will continuously start moving in negative direction. And what will happen? Now see the same situation of the same conductor. What will happen? These electrons will come on this side. Minus, 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 minus. Right? Minus, all the minus. And again see, if the electron has traveled from this place to a plus charge is created there. A plus charge is created there. So the plus charge will reside on the other side. So if a conductor is placed in an electric field, the electrons, those free electrons will feel a force that will be opposite to that of electric field. They will try to go to the another opposite side of the surface, and the positive charge will reside on this part of the surface. This is the mirror. Now assume one electron here, right? Now what is happening? This electric field is external electric field, right? This is external electric field. External electric field. Again, still this electric field existing at this place. This is the electron. This is the position of electron. Again, this electric field existing. Now these positive and these negative charge will start creating internal electric field. It's their own electric field. So what will happen? We know electric field for a negative charge is towards it. Like electrons, these negative charge will create electric field in this direction. And the electric field for a positive charge is away from the positive charge. That means these positive charge will start creating electric field in this direction. Right? So the net electric field becomes something like this, right? In this direction. Okay, so there is an internal electric field and internal electric field. Now we have two electric fields. Let's look at the situation, look at the current situation. This is the electron here. One was external electric field, that was E, and one is internal electric field due to the induction of this charge. The new charges are induced on this conductor. So electric field on internal electric field E internal will exist here, right? Again, the net electric field E net, let us say this point as point P. E net at point P is E external minus E internal. Minus E internal because the direction for both are opposite. Now, if E external is still greater than E internal, what will happen? So E net is there. So force on electron is nothing but now this time minus E into E minus E internal. Again, a force is existing. This force is still not zero. So again the force is existing. This means this electron will further move in this direction. Further. So further negative charge density will keep on increasing, keep on increasing, keep on. Positive charge will keep on increasing. This positive charge will keep on increasing on the other side. Negative charge on this side. So what will happen? The value of E internal will increase. Why? Because these electrons, these negative charge pools creates more denser electric field, and this positive charge also creates more denser field. So value of E internal will keep on increasing. Keep on increasing. There will come a time. There will be a time, because unless there is an electric field, till the moment there is a force of the electrons will keep on going, keep on changing its position, and the charge will keep on getting induced. So the E internal value will keep on increasing, and we know there are infinite number of electrons. there is no lack of electrons at all. So a situation will arise when this internal electric field will be equal to external electric field, and that moment will be E internal equal to E, which means the force will equal to 0. Force will equal to 0. And the E net is E minus E internal equal to 0. So the electrons will keep on moving till the moment electric field inside is 0. Till the moment electric field inside is 0. So this is the very basic and very important concept of a conductor. Very star mark concept of a conductor is that electric field inside is 0 for a conductor. A conductor will never let a charge or an electric field create or exist an electric field inside. The net electric field inside the conductor will always be 0. Okay, so please keep this point in mind. And where have we derived it from? So we use the concept, the definition that conductor has infinite number of free electrons. It will keep on moving till the point the net electric field reduces to 0. Okay, and now we apply this concept everywhere. For example, there is a question. First of all, a very basic question. This is a sphere. This is a conducting sphere. Conducting sphere, hollow sphere, okay? And there is a charge Q placed at a distance d from the center, and the radius of the sphere is capital R. Okay? Now what will happen here? Look, this positive charge plus Q will create an electric field inside this sphere, because it will spread its own electric field at this point, right? And the electric field, let us say O, electric field at O due to plus Q is nothing but, we know electric field due to a point charge KQ by ds. Okay, so this is the electric field due to this plus charge Q at this point O. Now we know there cannot exist an electric field inside a conductor. So what will happen? There will be electrons, some electrons on this surface, some electrons on this surface. They will face some electric field, some force on them. So what will happen? Negative charge will come on this surface, positive charge will come on this surface. So initially the electric field due to this charge is KQ by ds square in this direction. Now what has happened? This negative charge has been induced on this surface and this positive charge on this surface. So due to this negative charge, an internal electric field in this direction will start getting created, right? And also due to this positive charge, an electric field will start getting created, right? So there will exist an internal electric field to counter attack this external electric field and to make the net electric field inside the sphere as 0. Now what will happen? See, now the situation is, this is the sphere. External electric field at this point O is KQ by R. So this is the whole, this is the whole conducting sphere. Now this is KQ by, not R square, this is KQ by ds square. And there is an internal electric field which is generated due to this induced positive charge and induced negative charge. So this is our induced positive charge and this is our induced negative charge. So as we discussed earlier, there cannot exist any electric field inside this sphere, inside the conductor, and this is the whole conducting body. the complete solid conducting body. So what is the situation? E net inside should be equal to 0 for a conducting body. That means E internal minus E external should be equal to 0. E internal is E int that we assume, and E external is nothing but kq by d square equal to 0. That means the value of E internal is nothing but kq by d square. So we don't know the distribution of charge. We don't know how to distribute, but we know the charges will be distributed in such a way so that at each and every point of this conductor there will be zero electric field. And if anyone asks you what is the electric field due to charge plus q at O, so what will we say? Kq by d square. What is the electric field at point O due to this negatively induced charge? Sir, I don't know. You cannot tell. The distribution is not uniform. What is the electric field induced due to this charge plus q? Sir, I don't know. You don't know the distribution. But if someone asks you what is the electric field due to this combined positive and negative charge inside the sphere, so due to those induced charges, the electric field is equal to kq by d square. That we derive E internal equal to kq by d square. And if someone asks you what is the net electric field inside the conductor, sir, 0. Why? Because there cannot exist any electric field inside a conductor. So if someone asks you, okay, at the center you told that electric field is 0. What about that this point? Let us say this point as point 2. There it is the charge q, and due to the charge q, then electric field will be produced at point 2. What is the electric field at point 2? If someone just asks what is the electric field at point 2, you will for sure and with full confidence you will say, sir, 0. Why? Because inside a conductor there cannot exist any electric field. Now someone will ask, what is the electric field due to charge plus q at point 2? So first of all, for that we will have to know the distance between 2 and charge q, like point 2 and charge q. So let us say this distance is d2. Okay. So electric field at point 2 due to q, charge q, will be nothing but k into q by d2 square. Simply Coulomb's law. No need to think too much. Okay. But electric field net at point 2, 0. Why? Because inside the conductor. Now someone will ask, okay, so negative and positive charge is getting induced on this sphere. Why? To maintain the net electric field 0 in the conductor. So what will happen? Electric field at point 2 due to induced charge. Now you are going to tell me what will be the electric field at point 2 due to induced charge. Sir, very simple. This is the at point 2 there are two kinds of electric field. One is due to q and another is due to induced. So at point 2 if we see E2 due to q minus E2 due to induced charge. These are the two electric field and the sum should be equal to 0. And that means E2 due to induced charge, what will be its value? It will be as same as E2 due to q. Q, whatever amount of electric field q has produced at this point 2, the same amount of electric field is induced charge will produce at the point 2, but the direction will be opposite so that it can counter attack the electric field of q and make the net electric field 0. So electric field at point 2 due to induced charge is equal to, what is the value? Kq by d2 square. But direction is opposite. Due to q this is this, and due to internal charge this is this. So the direction will be completely opposite here. Okay. So we are gonna complete the today's lecture, finish today's lecture. But before finishing, I would like to give you a question that you will solve, and please solve it and show me in the next class. The question is, this is a conductor solid conductor and a charge Q. This is the center. This is the center, and a charge Q plus Q is given to this conductor. Plus Q is given to the conductor. So you have what you have to tell is charge distribution. Charge distribution, and there is a point P at d distance from center. Electric field at point P. What is the value? So first question is this. Second question is this. Just do it and show me in the next class. So till that, all the best and have a good day. Thank you.